In this video, I want to walk you through looking at the validation of the two models that we created in the previous exercise. So in this case, you can see I have my grinder error model, which used our default 4 learning techniques, and it has its own model validation, accuracy, root mean, square, Pearson, and the advanced, which is actually nothing more than a linear regression model. So we can see a little bit of difference here where it looks like the 4 learning technique model seems to be a little bit more accurate, higher Pearson score, lower RMSE, higher accuracy. So we can take a look at that model just by opening up viewing the model. And when you do view the model, you'll see some information. Here's the model name, what the goal was, the data set used, any of the filter information will be shown as well. And any exclusions applied from the training. We also can see what is the average value of the goal. So in our data set, average value is about 0.19, about 20% of the records had an error, and information about the training of the model. Then down below, we have our validation results. So we held back 20% of the records and did validation on this. Since this grinder error was either a 0 or 1 value, we get a rock curve here. So you can take a look at that, and it gives you a good indication of the behavior of the model as far as true positives versus false positive rates. If you want more information about what's being shown on this page, click on the little help area. It's going to give you some more detailed descriptions about how to read this curve, information about the values that show model accuracy, root mean square, Pearson, how to interpret those. In addition, we can go back and we can look at how did we actually configure this model. So in this case, we can see we're have the name, we can see what our goal is, we can see that we're using a lead average ensemble technique, and here are the learners that we had configured to run. Now this gives us a good idea about here's the model validation, and we can use that to help us determine if we think this is a good model or not a good model. In addition, if we want to dive in and look at the data in a little bit more detail, we have the ability to create signals and profiles, where signals is going to go through and look at our data and identify which features have the strongest correlation or strongest influence on the scoring of the goal. So in our case, since we're looking at the grinder being either a 0 or 1, it's going to identify which of those features have the highest influence on that particular goal. So we can see here after running those signals, the number of average cycles in the prior week has a very high correlation, or the highest correlation to the actual goal of the grinder. And by clicking on the average cycles, we can see here the different values and value ranges for the average cycles during the week. And here's what the average result is. So to look at this one, for example, coffee makers that made between 456 to 480 cups of coffee in the prior week had a 0.9% chance, 90% chance that they were going to have an error. So very high, and you can see a lot of this correlates. The higher the number of cycles, the more likely we were going to have a grinder error. And that seems to make sense to us just from thinking about it from a logical perspective. And again, more information, how to use the pages, just click on the help icon here and we'll bring some information over. In addition to signals to tell us which are some features that we may want to look at, and if we want to refine our models, what are the features that really make a difference to us, we can also create profiles on the data. The profiles are going to give us a view of how different groupings of features and values of features correlate to maximizing or minimizing the goal. So in this case, we're building groups of profiles of data up to 4 deep, meaning they'll have up to 4 different features within them that lead to the higher value of the grinder. So in that case, the higher the value of the grinder, the more likely it is to fail. So now that our profiles are complete, we can see different profiles which are grouping. So for example, starting with this one at the top, average cycles per week being in this range, my average goal, 66% of those are going to have a failure. If I then combine those with a grinder type of satellite, they're going to go up to be an 80% 83% chance of failure. Then if I go and have a pressure in this range, it goes up a little more. And if the temperature variance is in this range, it goes up slightly more. And you can see things such as a total number of records in our data set that um, have that occurrence or those occurrence of those four features. And then going down to profile number 2, which is an interesting one as well, is if I've got a spline driving rod, pump head, and I have an integrated grinder type, I can see right here, I automatically fail. All of the designs or all the coffee makers that have these two properties have an average goal of 1 already. They also have additional properties here because when I generate my profile, I'm looking for 4, and if there are the ability to group 4, it will do that. It doesn't have to, but it will. So that just tells me some more information, descriptive information about my data that may help me uncover things to look at, as well as may help me decide how I want to exclude features, use features as I build in my model or improve my model for the future. Now for this set of profiles, I use the maximize to true, so I'm looking for what are groupings of features that lead to failures. If I wanted to look for groupings of features that lead to success, I could generate new profiles, and instead of maximizing the goal in this case, I could minimize the goal. I could also change some of the settings like max depth, how many of the different records am I going to, or how many of the different features do I want to look for combinations on. So that's a little bit of an overview of our profiles to help you dig into data. And now the final thing I will do is take a look at predictive scoring. So we've created this model, it's available, we can use it, and if you do have records that you've loaded in the data set and we want to create predictive scores for those, we can. So I'm just going to create a scoring job for the grinder. I can decide if I want to have any filter, and in my case I'm actually going to create a new filter here. And if you remember when we set up our training, we had this record purpose field. So I've loaded in, and if I need to, I can load in additional data, and I put in the value of scoring. So I know these records need to be scored. So I'll only score those 1,000 records, create that filter. And as I set up to do my predictive scoring, I can choose some additional options. So for this scoring, I can choose if I want to see important features, or what are the features of this record that I'm scoring that have the highest influence on the actual prediction of the grinder error. So I'll say, okay, use 2. And then if I want to look at specific feature values for each record, I can determine if I want to add those in. For example, maybe I want to look at the average cycles in the prior week or average daily cycle variance versus last month, cleanings. If I want to add any of that information in, so I always have that for every record, I can do that as well. And now I can submit the job, and it's going to go through, use my predictive model here to predict those 1,000 records. One thing to note is you can, when you do create a new scoring job, we have the ability to allow you to upload additional data in the process. So if you do have a set of data records you want to append into your data set, you can do that as part of your scoring process as well. Once the scoring is completed, I can download the results. I've already done that. That's just going to give me a CSV file that I can open up, and I'll just show it in Excel. And what you're going to see in here is the record identifiers that I was trying to score, date, time, and what the goal value is predicted by the model. So I can see the different predictions here. And then the feature that I picked, cycle variance versus last month, I wanted to see this for every field, so I get to see that. And then since we configured it to show 2 important features, it's going to show 2 important features, and for each of those, which one is the has the highest influence on the score, and show you the weight of this feature on the score, as well as what the value is for that feature for the record. So we can see here for average daily cycles in the prior week, 322, that had a pretty high weight on the score. And then the second important feature was the variance versus last month for this particular record here at the top. and you can look through the data and it'll give you a little bit more information about what the score is, how it scored it, so you can dive into this data. So that wraps up this demonstration and shows you how you can create a model, load data, create a model, predict results, also do some data analytics and data investigations using signals and profiles.